This is Ms. Miner, and we are going to start Unit 8. And this is a unit where we're going to be talking about exponents. But before we move into exactly what we're going to talk about today, we're going to do a little bit of review, because when we start working with exponents, what we end up with a lot is a fraction that we have to simplify. And so we're going to just take a couple of these fractions. We're going to start with number 2 right here. And we are going to figure out how to simplify fractions. This is something we should have been practicing since the beginning of the year, but I also know that it's something that a lot of students struggle with. So we're just going to try and review how to simplify a fraction. And so I'm going to kind of give you some tips and some tricks and show you some different ways that you can simplify fractions. Okay, so whenever I have a fraction, what I'm looking for is what can I divide both of these numbers by? And I'm kind of thinking about what we call factoring. And factoring means breaking numbers out into different numbers that we can multiply together in order to get that number. So I know that if I start thinking about the number 72, what are some numbers that I can multiply together in order to get 72? And I also am kind of at the same time thinking in my mind about the number 60. What are some numbers that I multiply together to get the number 60? And is there a number that they have in common? So thinking about this, I know that 12 times 8, and this is what I'm thinking about in my mind. Oh, sorry, not 12 times 8. 12 times 6 is one way that I can get the number 72. Some of the other ways, maybe like 8 times 9 would be another way that I could get 72, right? But I'm just kind of thinking of, in my mind, numbers that I can multiply together to get 72. Then also, I think about numbers that I can multiply together to get 60. 6 times 10 would be 1, right? Another way that I could get 60 would be 12 times 5. And so I'm kind of looking for those numbers, and I'm thinking about those numbers that I multiplied together to make, let's take into account also 10 times 6. So I'm breaking those apart. I'm factoring those numbers. I'm thinking about what numbers can I multiply together to get 72? What numbers can I multiply together to get 60? And then once I've found some, then what happens is these are dividing each other, right? They're going to cancel each other out. And so once I have divided, so what I did was divide by 12 here, because that's the number they have in common, divide by 12 here, and that's going to give me 6 on top and a 5 on bottom, right? And so those numbers that are left over, my reduced fraction would be 6/5. Now, I don't necessarily have to find the largest common multiple, right? I don't have to find that. Let's take into account this other situation that I was talking about. What if I just figured out, oh, well, they both have a 6 in common? Well, then I would end up with the fraction 12/10. And maybe I notice, hey, both of these are even numbers, so they can both be reduced by 2, right? So then I would just reduce again if I needed to, and I would end up with the same result, right? So even if I didn't find the largest common multiple to start with, then I can still just reduce until I get the most simplified fraction, right? 6/5. Now, here's the thing, right? Maybe I just noticed from the very beginning that both of these had even numbers at the end. And so I just reduced both of these by 2 to start with, right? I'd end up with, 32. Oh, let's see. This goes in 3 times 36 times, and then 2 goes into 60 30 times, right? So there we go. Now I'm going down the right road. Okay, so now I have this fraction 36 30ths. I could reduce by 2 again, right? And I can just keep going a number of times until I finally end up with my most simplified fraction. So this would reduce to 1/18, and this would reduce to 15, and then I would reduce again by 2, right? And I would end up with 9. 15 to 2 would be, oh, that's not going to go, right? So I can't do 2 on both of those. So then I would do, of course, 3, which would give me the 6/5 I was looking for. Okay. So there we go. See, even Ms. Minor had to try a couple of numbers to make sure that I've factored it all the way out. And that's how we do it. We just kind of slowly kind of divide by the same number on top and bottom in order to finally get to our most simplified fraction. Now, it helps if I'm really good at thinking about my multiplication facts, right? So I could pick out 12 right from the very beginning because I have my 12 multiplication facts memorized. So I said, okay, well, I know that both of those numbers are multiples of 12, and so that helped me reduce it fairly quickly. So a good idea is practice your multiplication facts. So that during this unit, when you need to reduce fractions, you're getting that practice with your multiplication facts, and you can say, oh, well, those are both multiples of 12, and so this is going to reduce to 6/5, right? Let's try again. Reducing a fraction. Let's try number 4. 108 over 72. I want you to maybe pause the video, see if you can reduce this fraction on your own, then come back, check your work. Okay, I hope you recognize that both of these are multiples of 9. And so I can divide both of these by 9, right? 9 times 12 is 108, and 9 times 8 is 72. And so, oh, look, they're both even numbers, so I don't have this reduced as far as it can go. So let's reduce again. Let's try dividing by 2 again. Okay, then that's going to be 6, and that's going to be 4. And still, I have both even numbers, and so that can be reduced to 3/2. Okay, there's my most reduced fraction. And it doesn't matter if you have to divide a couple of times in order to get to your most reduced fraction. But we should be practicing multiplication facts. Practice factoring. Here's another way that you can reduce a fraction. And this is going to help you later on in Unit 9 when we start needing to reduce square roots, because we do it the same way. We essentially, in Unit 9, we'll find that we factor in order to reduce a square root, just like we factor in order to reduce a fraction. And so if I have 90 over 72, what I want to do is start thinking about what numbers do I multiply together to get 90. Well, I know I multiply 9 times 10, right? And then I could break this out even farther if I needed to. I could break this out into 3 times 3, which gives me 9, and 2 times 5, which gives me 10. So I've taken this and I've broken it out into all of its prime factors. We call that prime factorization. And so all of these numbers over here are prime numbers. They cannot be factored out any farther. I can do the same thing with 72. I know 72 is 8 times 9. And I can break that down even farther so that I have 8 would be 2 times 2 times 2, right? 4 times 2. And then 9 would be 3 times 3. And if I prime factor everything, then all I have to do is go through and I can cancel out any numbers that are the same. And then whatever is left over, 5 would be on top. And 2 times 2 would be left over on bottom. There's my most simplified fraction, 5/4. So another way to make sure that I have this reduced to its most simplified form is to prime factor everything and then just cancel out any pairs of numbers that are the same on top and bottom in order to get my most reduced fraction. In order to help you guys kind of start to think about this and figure it out, I've included a prime factorization chart in your notes. So if you look ahead, here's a prime factorization chart, and this is how we use it. Let's say I need to factor the number 90 in prime factorization, okay? And so I can use my prime factorization chart. What I would like you to do, though, in the next couple of units is start to figure out how to do this without the chart. By the time we get to our unit test review in Unit 9, when we're doing this with radicals, you'll need to be able to do it without the factorization chart. And so a way to do that is to kind of start looking at some of these numbers that we multiplied together in order to get the number we're looking for. So I look over here, I see my number that I need to reduce is 90. So I go to my chart, here's the number 90 right here. Here is its prime factorization. So I can write it out. 2 times 3 times 3 times 5. Then I need to reduce the number 72. And so I look up here at the number 72. Here is its prime factorization. 2 times 2 times 2 times 3 times 3. And then I can just go through and cancel out the pairs of numbers that cancel, and I can see what I have left over. 5/4. So you can use your prime factorization chart to kind of help you figure out what numbers we multiplied together. Also, this is going to help you figure out if you have a prime number at the end, right? I want both of these numbers to, in order to, so that they don't reduce any farther, right? Or maybe I have a 5 on top, right? And a 4 on the bottom. Well, the 5 is a prime number. So that's as far as it can be reduced. So then I know, right, that my fraction is reduced all the way down. Because even though this one is not a prime number, this one is, it can't be reduced anymore. So the only way this fraction would be reduced farther is if I had a multiple of 5 on the bottom, right? It would have to be a number that could be divided by 5 itself in order to be reduced any further. Okay, so that's how we're going to use our prime factorization chart. We're going to use it to help us reduce our fractions when we need to. Let's take a look now, though, at some fractions that have variables in them. And how are we going to reduce? I'm going to put up another page here real quick. Oh, let's do this. Okay. How do we reduce a fraction that has variables in it, right? So this one is 6x squared and 12x squared. Well, this is awesome because anytime I have the same number on top and bottom, they're going to cancel each other out, right? Those two are going to cancel each other out. They're the same number. And so then I can just reduce this one. And if I'm thinking about it, this is 2 times 3. That's the only numbers that we can multiply together to get 6. And then 12 would be 2 times 2 times 3, because 4 times 3 would be 12, right? Or 2 times 6 would be 12. And so I can start to cancel out the numbers that reduce here. And I end up with 1/2 as my final result. But what if, like in number 8, right? These numbers are not the same on top and bottom. this is n to the third, this is n to the fourth, then I have to factor it out. But remember, any exponent is just telling me how many times I'm multiplying that thing together. So I just break it out. This is 3 n's. This would be, 2 times 5 times n times n times n times n. And so I can start to reduce this way. And I can see what I have left over. 3/5 with an n on the bottom. There's my most reduced fraction. So anytime I have letters or variables, I can simplify by just breaking those apart. Okay, so there is our review of reducing fractions, and you can come back and watch this video anytime if you need some additional reminders how to reduce fractions.